Hi guys, welcome to Crayon. Okay, so this is the mind map that we've created with my Combined Science higher tier students. So we've got scalars and vectors, and there's vector from Despicable Me. I commit crimes with magnitude and direction. We've got our non-contact and contact forces, friction, drag, tension, air resistance, thrust. There's our non-contact forces. And then weight is mg, 9.8 newtons per kilogram on Earth. Remember that number. That number is important. There it is. And that brings us up to potential energy is mgh. Remember mg though is weight. Weight is a force. Work done is force times distance. So all of that links together. Just like that. There we go. And then we've got resultant forces, a single force that replaces all forces acting on an object. There's my balloon with its forces, cancel out the ones going opposite directions, which leaves us 200 newtons in the upwards direction. Elasticity Hookes Law, F is proportional to E. Elastic energy is a half ke squared, where k is the spring constant and E is the extension. Okay, now Hookes Law, force is directly proportional to E. With the spring constant k, the way to remember this is a bit of Father Ted. Feck. There we go. So then we go on to distance and displacement. There's the difference. Distance is how far we have travelled. Displacement is the distance from there to there. Okay, ignoring the route that we took. Then we've got distance time graphs. Constant speed, stationary, velocity time graphs, acceleration, constant speed. The area under the graph is the distance travelled, which gives us our acceleration, v minus u over t. V being final velocity, u being start velocity, t being time. Acceleration is measured in meters per second squared. And coming back up here, we go off to our terminal velocity. Here's our parachutist, whee, jumping out. And we've got drag acting upwards, weight acting down. When weight is equal to drag, the parachutist will travel at a constant speed, which is known as the terminal velocity. And then finally we go on to Newton's laws. There it is, a little bit of baby shark. Thanks a lot, Bob. Nice to see you enjoy your Friday nights just like I do. So, Newton's laws. Watch the baby shark video. An object in motion remains in motion, and an object at rest remains at rest unless acted upon by an external force. There's Voyager, bit of Star Trek for you. Voyager is a space probe that is continuing on its journey 40 odd years since it was launched. It's not got any fuel, it's carrying on the way it's going. Then we've got, just like little Herbie, forces, mass times acceleration. Newton's last law, action and reaction are equal and opposite. There we go. Acting in opposite directions, but the reaction is the same. Okay, so there we have paper 2, part 1, including Newton's laws Newton's laws Check out the video, it's catchy as anything. Okay, hope you've enjoyed it, guys. Good luck with your revision, good luck with your GCSE.